All right, happy Friday and welcome back to Everything Mathematics. And today we are going to finish this week with calculating the area of a trapezium. It was a full week. Starting off Monday, we look at the part 2 of 3 videos when we look at Heron's formula. Then the Tuesday, we look at half AB sine C. Then we went on to look at quadrilaterals, the concept of quadrilaterals with various examples on Wednesday. And yesterday, Thursday, we looked at how to calculate the area and perimeter of basic quadrilateral shapes. And we wrapped up with a nice problem solving that actually took me by surprise. I forgot it was there. Today, it's all about the area of a trapezium. So let's go into it. What is our objective for today? Simple. How to calculate the area of a trapezium. So let's look at it. This is basically in a nutshell. So remember, one of the main properties that you have to bear in mind when it comes to a trapezium is that there is a pair of parallel sides. A pair of parallel sides. Here, that pair is labeled as A and B. So whether the trapezium is drawn like this, like this, so I have it, or there's the other way. The other way is something like this with a 90-degree angle. Either way you twist and turn it, there will be a pair of parallel sides, right? And the formula to calculate the area states here below. So the area of a trapezium is equal to half the sum of the parallel sides times the height. So half the sum, meaning that you have to add the A and the B because that's the sum of the parallel sides. You find half of that and you multiply that by the height. Yep. And why am I writing it? Because it is right below here. Boom. So that's the area of the trapezium, mathematically speaking. So that is half AB, so half the sum of the parallel sides. That is what we read. Half the sum of the parallel sides, or you could say half A plus B, whatever comes to mind. But you need to know that A and B must be the parallel sides, the length of the parallel sides. And that will be multiplied by the vertical height. And I repeat, the vertical height. I've seen students multiply by the lateral height. If you do it by the lateral height, you will get the wrong answer. You wouldn't get the area. Good. And this is more general. Of course, there are other genuine ways of doing it. You could see this trapezium as a compound shape. If you have the information to get, let's say, this right triangle here and this right triangle here, you could also find the area by finding one area, two area, three area, and you combine them. Good? That's another way. I would say that's more work, but if you have, given that if let's say you have the height A and B, just use the one formula. It will work out to exactly what you want. So here, let's see this one. We have an example here. And the area again, let's do some. The area is very straightforward. So for this one, the formula, again, I always like to start with the formula. So the formula of a trapezium is equal to half A plus B times H. And in this case, we could see that A, well, again, it's up to you. I like to label either one, so A and B, or it could be B below and A below, B on top. It doesn't matter. It doesn't matter. In this case, it's only two, so it's whatever you want. So let's just replace some values there. So that will be half of, let's say, 8 plus 12 multiplied by our height, which in this case is 10. And basic maths from here, 8 plus 12, that is 20, and half of 20, that is 10. So our area here is 10 times 10, which is equal to 100 centimeter squared. And that's it. That's it. Believe it or not, we're done. Next one. Oh, this one is interesting, and the orientation here is changed. But again, you have to see these two sides here are the parallel sides. So this side here is parallel to this side here. Good. So that will be our A and our B, and this side here will be our height, the 7. Interesting. And we have to be careful there. I could easily see this throwing off some of us. So the area again of our trapezium, the area of a trapezium is half A plus B. Once you know the formula, you shouldn't have a problem, and I think sometimes that's where the problem comes, having the formula. And I know students sometimes have a problem with substituting values. So once you master those two things, this is a walk in the park. And I'm pretty sure this formula also comes in your CXC formula sheet. So probably nowadays you don't even have to learn this formula. For all I know, I don't know, times 7. So let's go. So 14, remember 14 is our parallel side, so we have 14 and 8, so we add just 2. So 14 plus 8, that will be 22. Half of 22 is 11 times 7, and 11 times 7 is 77 meters squared. So yes, people, this is as easy as they come. I wouldn't do 100 examples. The concept is very straightforward. However, of course, this could be much more interesting if you come in a problem solving maybe where we have to figure out which is which. So today we have a very short video. I think the point was drawn home. Today is Friday, TGIF, so I guess Friday we do a short one. Nah, just kidding. That is how it worked out today. So until next time, as always, like, share, subscribe, comment, turn on the notification bell if you haven't as yet. And on Monday, we're doing a very interesting topic, Pythagoras theory, one of the theories that I love the most in mathematics. So until then, you take care, have a blessed weekend, and until God bless everything mathematics.